This lesson, we're going to continue talking about normal distributions, and we are going to talk about especially finding the percentage from it, right? And the way that I'm going to show you how to find the percentage is using the table. There are different types of table, and the table that I'm going to use is given here, right? This is what I'm going to use. The first example I have is trying to make sure we understand the normal distribution curve. So it say the test score was normally distributed with the mean of 500, standard deviation of 95. What percentage of standard score less than 510 on the test, right? So if we wanted to find out percentage of the normal distributions, make sure this is the information we went over in the first session of normal distributions. But if we have a mean right here, we will have 50% from mean to the left side. So below 510, you should have 50%. Above 510, you have another 50%. So answer of this question is going to be 50%. But that's the basic information we need to have in order to continue to the next problem. So within the same problem, same normal distributions, they want to know what percent of the students score less than 650% on the test. So if we have normal distributions with 510, we want to know what percent of the students scores student less than 650, right? So this is the area that we're trying to look for. Less than 650. So what we need to do is we wanted to find the z-score first. So we do 650 minus 510. So that's going to be figuring out what value of standard deviations are there, right? Give you 140 divided by 95, which is going to be 1.47. And when you're looking at this table, I'm going to make it smaller so you can see the table at the same time. So when you're looking at this given table I have, it's just a 1 decimal place. So I'm going to again round this to the 1 decimal will give you 1.5. When I find 1.5 from the table, 1.5 is right there. Z-score 1.5. The area is your percentage. So or probabilities, right? Will be 0.9332. So if we wanted to change that to percentage, you're going to multiply by 100, so it will be 93.32%. Okay. Now let me write that. 1.5 on the table. So this is same as 1.5 z-score, and 1.5 on the table, your probability is going to be 0.9332. When you convert that into percent, it will be 93.32%. So we can say that approximately 93.32% of all test score were less than 650 score. Before I continue to the next example, I wanted to make sure, because if you look for this normal distributions chart or z-score table in different textbook or website, you will have different types of table. You will have the table with different numbers. The reason is because this is the table, it shows the whole thing out of the 100%, right? But there will be the table where it's just going to talk about one side of normal distributions. So for example, this is going to show whatever your number on the left side is what they're given. So if you have a value here, then whatever the left side. But there will be other table that it will give you only this side of the value. So with the same informations, 1.5, there will be some table that gives you only half of the area. So what you need to do in order to get the same number, you need to do 50% plus your percent that you found in order to find the whole thing, right? So there are different types of table out there. So make sure you understand why there are different table with different numbers given. There is another table that gives you on the right side of the value. This one is giving the left side of the value. That's why you could say when you find the z-score, all the value on the left side, it's already given on the table, so you didn't have to add the other half, right? Let's go over another problem. So this one is the normal distributions again with mean of 62, standard deviations of 6 pounds. Find the percentage. So we're going to do the same thing, finding a z-score, right? And look for that z-score from the table of the dog of this breed that weighs less than 55 pounds. So we wanted to find the percentage of dog that's less than 55 pounds. So let me write the normal distribution curve to get some idea, right? And mean is 62 and 55 should be somewhere right here, right? Let's say this is 55. Less than, so we're looking for this smaller. It is on the left side of the z-score, so we don't need to do anything from the value that you found. It's going to be what the table given, right? So let's find the z-score for that 55 first. So you will do 55 minus 62 divided by standard deviations. That gives you negative 7/6. That's negative 1.17. Again, the charts only gave you 1 decimal place, right? So let's round this. Let's round this. So it'll be negative 1.2. So this is going to be negative 1.2 and go back to the table, look for negative 1.2. Negative 1.2 is right here, which is going to be 0.1151 will be the probabilities. Go back to, so this is going to give you the area of 0.1151. So when you change that to the percentage, it will be 11.51%. Right? That's the value you got from the table. And change to percent, it will be 11.51%. Let's try another one, right? So the same thing, but this time more than 55 pounds. So I want to make sure you can see the other problem also. So this time, this is 62 and this is 55. And you wanted to find more than, so it will be this area. Remember, the area that you found on the chart was this one, 0.1151, right? So in order to find the other area, what you need to do is the whole thing had to be 100%, right? And this one was 11.51. Let's write that down again. So that will be 11.51%. So the other side, which is going to be more than 55 pounds, should be 100 minus 11.51. Since the charts table gives you on the left side area, in order to find the right side, you need to do 100 minus the percent given. So it will be 88.49%. So you could say 88.49% of dogs weighed more than 55 pounds.